as the channel manager for this East-South European territory. And typically the Asiovision is our unique partner for Israel market. So what we are doing and what we are, we are typically focused only for 3D technology. So 3D, how we can describe or what it can be, is that you can imagine any kind of the object, what you can describe by the value, like the dimensions, like the areas, like the other features or the parameters. Then is the 3D that what we can measure. Our sensors are primarily suitable for the inline inspection, for direct montage to the production plant. So we can sometimes meet the 3D systems on the metrology, but it's not our pool. We are mostly only in inline inspection. You can meet us in terms of the automation, in terms of the quality control, and also the optimization. I think that a couple of applications, what the motive was describing, is also suitable for the 3D measurements. So typically for the counting the natural materials is also capable to do with the 3D. Why to use the 3D is there is two major aspects. One of them is that you have the information about the height of all of the points in a field of view. So it is the main difference between the standard 2D cameras. And the another factor is our immunity, which the ambient light issues. Because I also have been working with the 2D cameras for a long time, and I all the time was saying that almost the 90% of the successful of the task is based on the lighting. So this is the part what can be fixed by the 3D. The company LMI is quite old company because we are the Canadians. We have started on the wood industry, but from that time I think that everything changed, and nowadays we are producing quite fancy and compact housing black aluminum sensors. Our global presence is almost everywhere. We are mostly using our distribution channel, like is the Asia for the Israel, but also, as you can see, all of the yellow dots is the other partners. In parallel to this, we also have our regional offices. I think that the closest one will be the Munich or Kerkrade or the Berlin. And this is the offices where we are capable to perform the testing of your objects. Yeah. What is our pillars? What is our major points? Our sensors are built as the smart technology. So what does this mean? Is that the sensor has all built it. So you don't need to program anything. You don't need to install any additional software. So when you open the box with the sensor, you can just start your application. We are trying to do our own chip level engineering. So it means that despite the crisis that was, or still it's between us, so we are still capable to deliver our sensors really fast because it's our own chips. Then let's talk about our products. So we have the products that are divided to 3 different principles of the scanning. One of the most popular is so-called laser triangulation, and it means that we are grabbing the profile during the part that is moving, and after the sequence we are collecting the surface. So this device is capable to scan in a 2D mode, like the profile scanner, or in a 3D mode as the surface data provider, but it has to have the movement. The second device is called fringe projection, or we are saying it as the snapshot. It's also capable to provide us the 3D image. And the main difference between the laser triangulation is that this is the stationary. So with these sensors, we don't need to have the movement for 3D measurement. The third technology is quite unique. it's called like confocal line technology. And I think it's not important what is the raw principle, but what is the capable of. This sensor is capable of scanning the transparent materials like is the glass and the plastic, and also really shiny materials. It can be the chroma finishes, it can be brushed aluminiums, and whatever else with a really high resolution. Here is the couple of families. We don't need to talk about them, but it's just the overview. What you can benefit from our sensors is the resolution and the speed. So our sensors can run with the resolution from single microns, and in terms of the speed, we can go up to the 10 kilohertz scanning rates. Also, we are providing these several sensors with the several type of the light. Typically, we have the red lasers and the blue lasers, and also the unique is the infrared lasers. And based on this combination, we can have the performance on the challenging surfaces as is the glass or glue or the metals or rubber. So whatever you want, let's say. Couple of points about our sides, about our strengths. Let's say we can do the 2D and the 3D measurement that I have been talking about it. But also we have the wide range of the sensor solution. So there is not a rule which type of the sensor will fit exactly on the specific applications, but we can still choose one of the principles. Also, our sensors are robot friendly. So we have the interface that can be connected directly to the robot, or you can go through the PLC to the robot. Typically, we are capable to communicate with almost all of the famous brands like the Universal Robots, KUKA, ABB, Fanuc, whatever. Easy integration is also our strength, because as I said, we don't need to install any software. All is inside the sensor, and inside the sensor it means that it has the integrated web server. So you will just open your web browser like standard website, and in the web browser you can set all of the optical settings. Also you can add the tools, and also you can do the decision of your measurements. And if you have the measurements, that you can decide what to do with them. So we can set exactly the output signal based on the okay or not okay part, or we can communicate every measurement through the communication protocols. So we are capable to run the Ethernet. We are also capable to run the serial communication. And in terms of the Ethernet, we are running the Ethernet IP, Modbus TCP, and the Profinet. Typical feature for the line profiles is that we can combine the sensors together, and based on that, we can highlight several features on your objects that can't be visible with using only the single sensor. So, for example, let's say the opposite layout. So it means that we are capable to scan and measure the thickness of the materials, like the bend of the rubber or thickness of the foils, and so on. Our design is all in one. So as I said, we can do the scan and measurement and the control in a single device. We don't need to have any external controller. So it means that it saves you some cost for the additional hardware. It also simplifies you the wiring, simplifies you the whole concept of your task. Every sensor are coming from our factory calibrated. So you do not need to take care about the calibration, because all is done during the production. Only the thing what you will need to do is the alignment, and the alignment means the adaptation of the coordinate system to the robot, for example, or based on your conveyor belt. Our sensors are also capable to do the artificial intelligence inside, or so-called the edge computing. I think it's buzzwords nowadays. Our interface has built more than 150 tools. So you can provide the simple measurements. You can also combine the profile measurements with the 3D measurements. You can do the filtering. You can do the singularity of the objects. And I think that our possibilities are really wide. What is nice on it? Our software capabilities is free of charge. So if you will buy the sensor, then all is included with the hardware. The typical images that are coming from our sensors is the intensity data. It's a similar image like you can receive from a standard 2D camera, but also you can have the 3D point cloud, the information about all of the X and Y and Z information for single points, for every single point. Based on that, you can receive this kind of the data, and then it's on your decision on our recommendation which data you will use for the evaluation. So of course you can do the combination. What is the typical application what we are doing? So some of them can be, for example, the location and the measuring the diameter of, in this case, is the hole. We can measure the circularity, of course. We can measure the position of the hole. We can measure the edges of this hole. The second image is talking about the possibility of measuring the profile on the tires. So it's typical for the rubber and tire industry. You can read the letters from the sides, but also you can measure the width and depth of the individual grooves on your tire, for example. Some of the typical applications can be also the applying the glue on your object. So then we have developed the tool that is called the track tool. And based on the track tool, you will learn the sensor where the glue should be. And the tool will evaluate if it's the continuous, if it's not tiered, and also if it's in a good position, if it's the good volume, if it's a good width and height. So this is all of the information that can be provided from the sensor. The second image is the volumetric measurement of the engine. I have also spoke a little bit about the AI. Our AI approach is like the turnkey solution. We really develop the AI solution based on the customer needs. So we currently don't have any, let's say, prepared things, but we are trying to find the good combination of the models that will definitely fit your application. It can be the measuring the vegetables, fruits, but also it can be the parts from the automotive. But some of them have to be somehow adapted. With our AI solution, we will also provide you with the custom-made the HMI based on your needs. So you will tell us whatever you wanted to see on the screen. For example, this is a couple of our HMIs that we have built in the past. Sometimes can happen that our built capabilities or built tools is simply not enough. In this term, we are providing the SDK libraries, and with data, then you can use the external third-party software, like for example the Halcon or the Asiovision, or you can program your own application based on the C++ or C# or other languages. This is the SDK. Also, we are providing the GDK, and the GDK gives you the ability to program your own tool that you can integrate back to the sensor. And in this case, you will be running the evaluation of your tool inside the sensor on the performance of the sensor. The other typical applications can be during the bumping. For example, we can measure the planes, several angles, the presence and absence of the holes, the position of the holes, whatever we can think. Also, for example, the flatness. In terms of the food and food processing, we can do also different things, different tasks. For example, it can be the counting of random or the natural materials, like is the nuts. Also, we can measure the shrimps, for example, or provide the sorting of fishes or another materials. And also we can optimize your cutting process based on the accumulated volume. We can say to your cutter that the volume was achieved, and then in your packaging you will be sure that you have the enough weight of the material, like for example the cheese or the piece of the metal, piece of the meal, and so on. EV battery is also rapidly increasing the market. We are definitely capable of doing the several tasks. Some of them can be the coating of the electrodes. Some of them can be the welding seam inspection, if it's the good weld or not good weld. Also the present absence of the parts as is the connectors or the wires. Also we can measure the thickness and so on and so on. Now, that is really a huge potential. The part cell dimensions and defect detections. Since our sensors are capable to measure up to the 2 meters with a single device, then it's really suitable for the part cell shops, for example. And the device can do the dimensioning of the boxes. It also can provide you the information of the position of boxes to, for example, to robot for the automatic depalletization or palletization. And also in parallel or in advance, it can give you the information if your boxes is not damaged. Another pick and place application, you can combine if all of the components are present on your, for example, your mobile phone, and then also you will provide the information about position of your parts to picking up. Dynamic guidance of the robot is the another tasks. In this way, it's a really time-saving process because the sensors are in a real time providing you the information about the position of the roof, and based on that you can automatically offset the robot while it's assembling the top sheet of the metal. The another common application in automotive is a gap and flash application. So typically we can do this in a body in white shop, and also we can do this on the finished car when it has the coatings. So we have the two possibilities. We can do this with the snapshot, but also we can do this with the laser line profilers. In this video, it's our case study that are coming from the German producer, and you can also see much more information on our YouTube channel if you are interested in this. Another can be the complex small parts inspection, like the pin inspection or the coplanarity of the pins, the position of the pins, and so on. So CE market is also really big, and since our resolutions are on the micron levels, so we can fix this application. Couple of applications that are coming or that are suitable for the confocal line sensor. I haven't tell you that the confocal line sensor can see through the material. It can be maybe similar to the hyperspectral things like the Moti was presenting, but our condition have to be that the material is transparent. It's exactly the example of the mobile phone, for example. You can separate the layers of the covering glass with the layer of the display, with the touch layer, and also the housing layer. And then you can do the measurement in between of these layers. Another can be the blister inspection. So sometimes we are meeting the applications where the blister have to be hermetically sealed. So it means that our sensors is trying to look at the air bubbles inside the glue layer. It goes through the plastic package and just checking if there is no air presence. Oh, this is nothing. Just for example, what is our confocal line sensors capable? This is the example of the 3 micron level deep scratch on the glass surface. So definitely, let's say we can scan the glass and check the defects on it. Also, one of the common applications can be the roughness measurement. We are capable to do the roughness on the micron levels and also on the submicron. So this is the example of the printed parts. And of course, there is plenty of other applications. I think that our time is over. If am I right, then I will share the presentation with the rest of you. Then you can check the other things what we can do. Just the 4 things I would like to remember, or that I would like to know that you remember, that our sensors are all in one. You don't need to have any external things. Our sensors are fast and precise. We don't need to have the external controller, and our software is web-based. So please feel free to don't hesitate to contact me, Jackie, or Moti if you have some project that you think our solution can fit your condition, and I will be really pleased to discuss our possibilities and the sensors.
Thank you very much, Ivo.